Today we will study rigid body motions in modern robotics. Here one example. Suppose this one is a rigid body with two reference frame fixed. One is D and the other is C. D coincide with the stationary reference frame, ground frame. So S and D here. C is this reference frame. This is origin, say 0, 0. This one 3, 1. Reference frame is X, Y here. We want to displace this body this way. First rotation about origin and then after 45 degree it achieves this position. Again first it rotating about this reference frame S this way and it displaces this way. So final position of this point 3, 1 is here. We want to find the final position of this point. This one for this is the vector R. If you rotate this body to 90 degree, it overlap with this. So we have to represent R with respect to S frame. So we have to multiply with rotation matrix. This reference frame X, this one Y. But if you rotate this, it becomes PR. This one is 90. So rotation matrix P is what? Cos 90 minus sin 90, sin 90, cos 90. 0, minus 1, 1, 0. This one is P vector. Okay. So initial body is rotated this way and then after 45 degree. So we have to put this vector here to find the final position of this point here. So it is PR plus P. We get R dash. PR plus P. Final position. Triangle law for vector addition. Now orientation of C. See, this one is x-axis here and for ground frame it is x here. So this reference frame is at an angle of pi 180. So rotation matrix for this frame R is cos 180 minus sin 180, sin 180, cos 180. So minus 1, 0, 0, minus 1. We can achieve this position rotating about origin, thereafter displacing 45 degrees. Here something different. This one we are now pivot point is 0, 2. See here, this is the pivot point and we are rotating. This is building, pivot is here and we are rotating 90 degree to achieve this position. So here we have rotation only, no displacement. Screw system. Again, this one is the pivot point. We have welded with this point, say this, and we are rotating this way to achieve this position, C dash. After rotation and translation, the final orientation of C, this one is here, that is C dash with respect to S. So R dash, what about the orientation? So we have to multiply P with R, 0, minus 1, 1, 0, minus 1, 0, 0, minus 1, we get this 0, 1, minus 1, 0. So thus PR is 0, 1, minus 1, 0. So orientation of C dash in S frame is minus 90 or 270 because of this one is X and this one is here X. So it is rotated by 90 degree in clockwise, so minus 90. For the position of C dash, so R dash is PR plus P. P is rotation matrix 0, minus 1, 1, 0, 3, 1. It is in S frame. So we have to represent in rotated by this plus 2, 2. P is 2, 2 here. See P is according to geometry 2, 2. So after multiplication we get minus 1, 3, 2, 2. So 1, 5. This is the final position of C. That is 3, 1. Final position of 3, 1 is 1, 5. Initially the body rotates about 0, 0 by 90 degree counterclockwise, and then after it displaces by p 2, 2 amount in s prime at an angle of 45 with respect to this axis. Now we can achieve this final position and orientation just by rotation. We have performed already about a fixed point as 0, 2, not origin. This one 0, 2, about this point we have rotated this way, only rotation only. For this we are shifting the origin to s hk 0, 2. New coordinates of r in x dash s y dash frame are r minus s, that is 3, 1 minus 0, 2, which is 3, minus 1. See, focus here. This one is s, this one is new origin. This one is r vector, arrow is here. This one is s vector, arrow is here. We want to find this vector. So applying triangle law for vector addition, s plus question mark equal to r. So question mark is r minus s. So this one is r minus s, and this one is also rotated by 90 degree this way, or here rotation only. So p into 3, minus 1, when it is rotated by 90 degree counterclockwise, the coordinates becomes p into r minus s. So 0, minus 1, 1, 0, 3, minus 1, 1, 3. Say x dash y dash, because of it is in x dash s y dash system. But shifting the origin, see here, this one is old axis x o y, this one is x dash o dash y dash. Suppose new origin is h, k. We have shifted the origin to h, k. Suppose the point P is here. According to old system, its x coordinate is x, and according to new system, x coordinate is x dash, and this one is hk. So this one is s. So x dash is x minus s. Similarly, y dash is y minus k. So here x dash is 1, but we know that x dash is x minus h equal to 1, but h equal to 0, so x equal to 1. Here y dash is 3, so y minus k equal to 3, but k equal to 2 implies y equal to 5. How can we know around which point other than origin should be rotated by 90 degree counterclockwise to achieve the same final position? We don't know around which point we have to rotate. So for this, we will ask with maths. By example, r dash is p into r minus s plus s. We have derived this by example, Einstein logic. Example is not another way to study, but the only way. So using r dash is p into r minus s plus s, we want to find about which point we have to rotate. 1, 5 we want the final position. P is this. R minus s we have obtained this one. 3, 1 minus h, k plus h, k. Minus h, k here. This is r, this is s. So 1, 5, 0 minus 1, 3 minus h, 1 minus k plus sk. 1, 5 minus 1 plus k, 3 minus h plus hk. This one. Solving this, we get h equal to 0 and k equal to 2. This way we can know around which point we have to rotate a rigid body to achieve the same final position. Here we require same orientation also. So beta is 90, this one. This beta is 90. Now we are arising a question, can we achieve same final position orientation with beta not equal to 90 with respect to some s, h, k other than origin? Obviously, we can achieve same final position but not orientation. Let's take beta 60, applying r dash equal to p into r minus s plus s. 1, 5. P we have taken 60, so cos 60 minus sin 60, cos 60, 3 minus h, 1 minus k plus hk. Using this, we have two linear equations with a different slope. So there is unique solution. So we can find the point about which we have to rotate. Sorry, we have to rotate, but we get final position, but we can't get the orientation, required orientation. Do you know about the slope? We know that the equation of line ax plus by plus c equal to 0 in a plane a square plus b square not equal to 0. And the slope of the line is minus a by b. Suppose 2 point p x1 and x2 are to satisfy the equation. So ax2 plus by2 plus c equal to 0, ax1 plus by1 plus c equal to 0. Subtracting this, we get a into x2 minus x1 plus b into y2 minus 1 equal to 0. The slope is m equal to y2 minus y1 upon x2 minus x1 minus a by b. Now we are creating a question, interesting question. What about if we consider beta tends to 0? Here we have taken beta 60. According to me, for this point the rotation is 90 degree. We have considered 60 degree, but if we consider nearly 0 angle, the reference point about which we have to rotate is goes to infinity. So for small angle, we get this much of displacement. Okay.